Alright, hey guys, so I'm going to demonstrate the Deep Learning for Java user interface toolkit. So the use case for this is a trading bot for Pump.fun. So just going to Pump.fun, it's a website where anyone can launch a cryptocurrency on the Solana blockchain. And I've been tracking a lot of these coins' historical trades. And what the neural network attempts to do is predict future prices using the last 15 trades that have been made on the Pump.fun exchange. And some of these models have converged quite nicely. This one had a score of 3.63 when it started, and it's now at 0.00012. And the system randomly generates over 1,000 different neural networks and trains 5 at a time. So we can see that the activation functions, it takes price, volume, and whether it's a buy or sell order or neither, like an entry order. And it calculates ReLU identity function, and if it's a ReLU function, it could either be a regular ReLU function or it could be a leaky ReLU function with a random alpha, where alpha is the amount that it decreases, the f of x decreases when it's in a negative domain space. So the rate could be between 0.05 and 0.1. So it randomly generates a neural network with between 3 and 8 dense layers. We're looking at one right here. It has a identity function where leaky ReLU alpha equals 1. Leaky ReLU alpha equals 1 is identity function. This one is a regular ReLU function where alpha equals 0. That would result in categorical regression, so it can classify states in the hidden layers that it's in. It can classify states as being greater than 0 or less than 0. Now, if it's a ReLU function, there's a 50% chance that it uses leaky ReLU, where negative domains result in x times alpha, where alpha is a random value between 0.01 and 0.1. We can see the layers activation results on average, layer parameter histogram, layer updates histogram. So there's a lot of insight that we can gain from this. Let's go through this whole network architecture. It randomly generates these neural networks. The first layer has a random number of neurons between 75 and 1,000. And the number of neurons in the first layer is determined by also not just a random number, but it also adds to that number 25 times the number of hidden layers. That way it makes sure that there's enough input neurons for a large number of hidden layers. So this takes 45 inputs, which is our 15 past trades. And then it starts with a layer size of 184, which is randomly generated. And it plugs that into a ReLU function, which is going to result in categorical classification and in a regression setting. Dense layer 1 is another ReLU method with a alpha equal to 0, so that's a regular ReLU. Dense layer 2 has a activation function because alpha is equal to 1. When leaky ReLU has an alpha equal to 1, it's just going to be f of x. It's not going to be a regular ReLU function. So if ReLU function is a foreign term to all of you, I'm going to show you what the ReLU function looks like. So it's 0 when x is less than 0, and it's x when x is greater than 0. Now, there's a 50% chance it uses a ReLU function where alpha equals 0. But then there's also another 50% chance that all ReLU functions use a random alpha for leaky ReLU. So just to go over what leaky ReLU is, when x is greater than or equal to 0, leaky ReLU is equal to x. When x is less than 0, leaky ReLU is equal to alpha times x. In this case, alpha is 0.01. Now the bot randomly generates an alpha between 0.01 and 0.1. So the alpha is randomly set for leaky ReLU. Now, leaky ReLU prevents the dying ReLU problem, where values are forced into a non-zero slope, resulting in missing data. So the negative value on leaky ReLU preserves negative domain inputs. So I've also configured this so that I can print to the console back-tested trading results. I'm not doing that at the moment, but I am printing R-squared values. So I am printing R-squared values to the screen. And we can look at some of the other neural networks it's generated. This is another one that has a score of, where its score value here, model score, is mean squared error. This one has 5 dense layers. This one has 7 dense layers. We'll take a look at them. So it's using ReLU, not leaky ReLU. Another ReLU function. Another ReLU function. Yet another ReLU function. Now an identity function, because ReLU's alpha is equal to 1 here, as you can see. Another identity function. Another identity function. Another identity function. So there seems to be some serial correlation in the alpha values for leaky ReLU on this model. Let's try to find one that has an alpha of greater than 0 but less than 1. Okay, this isn't going to be it because this model's using a 0 alpha. It looks like all the models are using an alpha of 0, so there's some correlation in the randomly generated values from Java. But I have seen models with an alpha of 0.01 to 0.1 in the past where it's a random number. Okay, here's one where the leaky ReLU alpha oh, it looks like it detached. Must have crashed. Oh well, we're still training models. Anyways, that's about it for this video.